Hello, tech enthusiasts. We are back for another exciting episode in our FinGreat fintech series. As you recall, we've set up our GoLang and Next.js environments, and now we are ready to start developing significant parts of our application, beginning with the user module. Today's primary focus is CRUD operations. For those unfamiliar, CRUD stands for Create, Read, Update, and Delete. These are the fundamental operations that helps us effectively manage user data. We will then switch our focus to authentication, a critical aspect of any fintech application. This process verifies our users' identities, ensuring they are who they claim to be. We will guide you through the implementation of user registration and login functions, teach you to securely hash and store passwords, and demonstrate how to compare them during user login. We will also delve into the world of JSON Web Token, JWT for short, which play a key role in maintaining secure user sessions. But we are not stopping there. We will also explore authorization and essential security aspects that defines what action our authenticated users can and cannot perform within our application. By the time we conclude this episode, we will have a robust and secure user module, forming an integral part of our FinGreat application. Looking ahead, our next episode will introduce the account module. Here, we will create accounts in various currencies, facilitate user-to-user money transfers, and explain the inner workings of interbank transfers and the role of settlement platforms. If you are finding value in this series, please give us a thumbs up and share it with your network. Alright guys, let's get our hands dirty. So currently on the screen, I have a table for users that I've created using dbdiagram.io. And with this tool, you get to visualize what your table looks like. You get to easily create your table. Then finally, you can export it to whichever variant of SQL you want to work with. So now let's quickly go over what we have for our users table. So we have the ID, we have the email, which is going to uniquely identify the users. As you can see, it's a unique field. We have the hashed password because we are going to be working with an hashed password. Then we have the time information signifying when the user was created as well as when last the user was updated. So those are the information we'll be working with. It's quite basic and straight to the point. So now that we have that information out of the way, we can go ahead and export it to Postgres. So after exporting, this is what the file looks like. So we have this information in Postgres format and we are good to go. So that's the first part. The second part is actually going to be setting up our DB, creating the Postgres server, and so on. So going back into my code, this was where we left off in the last episode. So now to manage our DB and related activities, I'm going to create a new folder called DB. And that's it. Then next I want to create another folder called migrations. Because also I mentioned in the last episode that we are going to be working with migrations. But technically in the past, we don't usually bother ourselves with this. We tend to use tools that does these migrations for us. So for instance, for me coming from the Django side, Django tends to create the migrations for you without you knowing what is going on. And also it uses ORM, which means you don't have to work with SQL. But in this case, we are going to do a bit of SQL, not entirely everything, but something close enough. So also we are going to have a folder for migrations. Then within here, we want to generate our migrations. So if we come back to our browser, this is where migrate comes in. So again, if you've not installed this, you'll be needing to do that now. So let's come back to our code. If you've installed migrate, you can type in migrate-help to see the options you are provided with. Okay? And in this case, the option we want to work with is the create because we want to create migration. So let's try it out. Let's clear this out. You type in migrate, then you specify create because we want to create. Then you specify -est to signify that what extension do you want to work with. In this case, it's going to be SQL. Then also you have -dir to specify what directory you want to create this into. And the directory is going to be db migrations. Then also you can specify if it's going to be in a sequential order or not. And it being in a sequential order makes more sense. So we can do that by having -seq. Then finally, we can specify the name of the migration we want to generate. So technically, there are other options you can use, but I think this is what you need. So here we can just have something like user underscore setup, or let's use user.setup. I think underscore makes more sense. Underscore is more of a text than dash. And as you can see, it generated the user underscore setup migrations for us. So the way migrations works is you have a up, which makes the migration, and you have a down, which rolls back what migration you've made. So what this means is that if you make a migration and you're successful with it, you don't just go ahead and change it if you need to change anything. Instead, you make a new migration and make your changes within that new migration, okay? So that's technically how it works. So now that we have these two migrations, we can use the information from our SQL to fill it up. However, it doesn't make sense to be typing this out every time we have to make migrations. And this is where the next tool we'll be using comes up. So yeah, back in my browser, I've opened up this URL and we're talking about GNU Make. And this works with your make file to make working with commands easier, okay? Everything revolves around make. So as you can see, you can just read more about it. So we have a make file where you define all your commands and you can use make to run it. And before we proceed, you want to download this, and it's quite self-explanatory. So yeah, I believe we can go through that and get started. So once we've downloaded it, we should have access to make. We'll type it. You can see that it recognizes it, which means it's available. So next thing I want to do here is to create a new file and call it make file. Okay? And now I can specify what operations I want to perform. In this case, I want to create a migration. And I can call this create migration. And if you feel this is even too long, you can even still short it. And I can call this even CM to make it shorter. But make sure that you make it such that people who you want to work with recognizes it. So I can make a comment just to let people know. I can say hash create a new migration. Then finally, I can specify what operation I want to perform, what command I want to execute. So I can copy all this and paste here. So the only issue I have here is that this would only create user setup migrations, and that won't be the case. So we are naming this user setup because that's what the migration we want to create entails. We want to create user setup, okay? So in case we want to maybe add account information or other information, we want to name it accordingly. So in that case, we want to be able to specify a variable here. So we can do that by having $, then the name of the variable in brackets. So in this case is going to be name. So this is going to use that variable in this place. So let's test it out. First, I'll delete the two variations we have here. Then next, I can say make C_m, then the name, which is going to be user_setup. And as you can see, it did created the migrations again, and we are good to go. So yeah, that's about that. So now let's talk about the migrations itself. So in here, we want to paste the migrations we want to run. In this case, we want to be able to create the user table. And yeah, we can copy all we have here. We don't have to think about it to write it. We can just copy it out and paste here. And we are good. And yeah, as you can see, we have two variants. We have up and down. So up means this is what will happen when we run it. And that means this is what will happen when we roll back. And what do we want to happen when we roll back? And that's literally removing the user's table. And we can just do drop table if exists users, like that. Okay, so that looks cool. So far so good. We've been able to make migrations. We've been able to fill in our migrations. But next thing is actually to migrate. So we can't actually migrate now because a prerequisite of migrating is a database, which we don't have. And in this case, we are going to employ the use of Docker and Docker Compose to achieve this. We're going to be creating a Postgres server. Then we're going to create a database. Then we can migrate into that database. So let's do this. So to be able to perform this operation, you need to have Docker and Docker Compose installed. And one way to check is if you type, let's clear this out. If you type in Docker, you get to see information about Docker. If you type in Docker Compose, you get to see information about it as well. And I'll quickly just pull up a link where you can install Docker. So here is Docker. And if you go through this, you should be able to install Docker and Docker Compose as well. So yeah, I won't bother too much about this. Let's go back into our code. And now we can create a Docker Compose file. So here we're going to have new file, docker-compose.yml. And in here, we want to set up the Postgres service. So we're going to specify a version, which is going to be version 3. We're going to define services. And here we're going to have Postgres. Then here we can specify the container name. And here we're going to have FinGreat _ Postgres. Next, we can specify the image we are using. And in this case, I want to use Postgres image. I want to use version 15-Alpine, like that. So I have this image within my system already. However, if you don't have it, it's going to pull it and set things up by default. So next, I want to have the environment. In this case, I'm going to have the Postgres user, everything in capital letter. And my user is going to be root. Then I'm going to have the Postgres password, which is going to be secret, like that. Then finally, I can specify what port it should run on. So ports. So externally, it's going to run on 5432. And internally, it's still going to run on the same port, 5432. And those are the configurations we would need to set up our Postgres service. And to actually run this, we can have docker-compose up. And this is going to start things up. And if you're able to see database system is ready to accept connections, it means you are successful in setting up your Postgres service. And one way to confirm this is to come back here, go to Docker dashboard, and you get to see your service running. So if we see here, we get FinGreat Postgres running. All right, that looks cool. So currently you can see that everything is just running out. Sometimes we don't want to run it this way. So we can close this, Ctrl+C to stop this. So instead of running Docker Compose up, we can run Docker Compose up -d to run it in a discharge mode. Okay. So as you can see, it's still running, but it's not showing all this information and it's not holding up our terminal. So we can perform every other operation we want to do. So technically, Docker Compose up -d doesn't feel too long. And you might think we don't need a makefile for this. But again, it can still even be shorter. So we can come back to makefile and just have p up. And again, you can commit it so that people who wants to use it can understand. Postgres up, create Postgres server. Then also, we will need an opposite of this in case we want to stop our server. We can have p down. So we can copy this. And this will be Postgres down. And this is drop or delete. Postgres server. So now we can work with the command itself, and that's quite straightforward. Docker -compose up-d, and this would be Docker -compose down. Okay, so now we can have make p_up to start the server, and we can have make p_down to drop the server. And with that, we are good. So the next line of action is to actually have a database, because at the moment, defaults will be created, but we don't even know about this default. We want to create one we can work with. And that's quite easy. We can easily access Postgres service and create our DB by accessing the Postgres service and typing the necessary command. But how do we actually access the service? And we can easily do that with Docker. So let's clear this out. We can have Docker exec-it, exec-it. Then the name of the container, in this case, let's verify. Okay, the container is no longer running, so let's make it run. So make p-up. All right, so now the container is running again. We can confirm this. Okay, so our container name is FinGreat_Postgres. It should be postgres, not postgres. So let's correct that. Let's drop this. Let's update this. So this should be postgres, and that's okay. Can clear this out. Can do make p-up again. And now let's check again. So now it's Postgres. So to create a DB, we can access the Postgres server by having Docker exec-it, then the FinGreat_Postgres, which is the container name. So now we have access to the Postgres server, but we want to perform an operation directly, and the operation we want to perform is to create the DB. So this will be create DB. Then we can specify the username. So --username. In this case, if you remember, the username is root. Then also we can specify the owner, which is also going to be the same as root since we didn't specify it differently. Then finally, we can specify the name of the DB, and I'll call this FinGreat_DB, like that. So I'll click enter, and that should create the DB, which we can't access at the moment. And technically, you can exec into the Postgres server and view all the DBs as well, but that won't be quite interesting. So instead of doing that, we can look for a visual way to actually view it. So again, to ensure that we can easily do this, create a DB or drop it, we can as well just copy this as well. I'll come back to our make file, and we can have this as DB up. And I think that's self-explanatory. There's no need to have a comment for this. So we can paste that command like this and just ensure that things are how it should be. So if we have a DB up, then we should have a DB down. So let's copy this and just paste here and change this to down. And now we can remove owner. That won't be necessary for the down operation. Then also this is going to be drop DB. Okay, so now these are the commands to create or delete DB, but we've actually not been able to view our DB so far. And I have a tool to do that, so we can actually close this. And the tool I'll be using is called Table Plus. So we can easily download this by searching for it and downloading it. It should be quite straightforward. So now I want to click on this plus and add a server. In this case, I'm adding a Postgres server. So I'm going to call it FinGreat. So by default, it's using the default localhost, then the default port. However, here we need to specify the username, which is root, then the password, which is secret. Then the database name, we can access it here. but I don't think that will be necessary. We can see the databases we have and access them later on. So let's connect. So yeah, no database selected. So I can have Command K to select a database. And by default, you get to see other databases that were created. However, the one we're interested in is the FinGreat DB. And we can open it. And we can click here to see the tables we have. We don't have any at the moment. So let's come back here. So now we've been able to see our DB and confirm that it actually was created. So let's test if we can drop the DB. So make DB down. And we are getting this error because we are currently accessing that DB. So again, we are accessing the DB here. So if I change the DB with Command K and change it to root, now we are accessing a different DB and I can close this. Okay, so we are currently accessing the root DB. And if I come back to my code, I should be able to delete this DB. And as you can see, it was easily deleted. So if I come back to table plus Command K, I don't see FinGreat DB again. So it looks like our commands are working. So again, these are going to be needed in case you are not working alone and you want other people to just be able to fast track their setup. Okay, so now let's return back to DB up to create the DB, and that was created successfully. And now if we come back here, close this, and have Command K, we get to see the FinGreat DB again. And we can close this. All right, so the next step is done. We have our DB, we have our Postgres server, we have our migrations. So now let's actually make our migration into our Postgres DB. So again, I'll start by clearing this. If we type migrate, we get to see the options we have. So if you type in migrate, you can specify any of these options to make your migration work. So to achieve our aim, we can start by typing migrate. Then we specify the path of our migration, so dash path. In this case, it's going to be DB migrations. Then we specify the database we want to migrate to. So we have database. Then we're going to coin up this Postgres URL like this, Postgres. Then the username, root, secrets, the password. Then at the host, local host. Then the port 5432. Then slash the DB name. In this case, FinGreat _DB. So by default, this would not work. So one more information you need to provide is the SSL mode. So you can add that as a query param. So we have SSL mode, which is disabled. Like that. Then finally, you can specify that you want to up this migration. And it's going to look for the migrate up and run that. So yeah, let's click on enter. Oh, okay, I used a wrong note. It should be disable, not disabled. Enter. All right. So as you can see, the operation was successful. And if we come back to this and we refresh, we see that we have the users table. And we have all the information we've provided. We have the schema migrations information as well. And this is more or less a schema migration monitor. Okay. So the dirty situation is false because everything is working as it should be. So in case you fall into a wrong migration where the dirty becomes true and you are not able to migrate again, you probably want to manually do this, set this to false, revert your migration and remigrate. So those are just something I thought I should share. All right, so it looks like our migration was successful. And again, we'll need to copy this and come back here, and I can say up, add a comment, run migrate up, paste my command. Okay, so the same thing for down. We can have down. Again, we have run migration down, migrate down. I will paste this. And the only difference we want to have here is the down. So now we can say make m_down. So it's going to request if you want to make it down, and I'll say yes. And if we come back here, if we refresh, you find out that the user's table is out. And now if you check your schema migrations, you don't have any information because it has reverted it. So back here, we can make migrations up again. And our migration should be up and running again. All right, so everything looks cool so far. And let's take a break and we'll continue after some minutes off. So now that we have our DB working and our migrations made, we want to introduce Sqlc into the equation. So like I said in the last episode, Sqlc is meant to make our life easy when working with SQL. And based on that, we're going to create some other folders. The first one being a queries folder. So in this folder, we are going to have our queries in which Sqlc is going to transform into Go language, okay? Then finally, we want to have another folder where our Sqlc setup is going to reside. And I'll call this Sqlc so that it's very obvious. So finally, we can then create our Sqlc configuration. And before we delve into that, let's go back into our browser. Everything we are doing has its information stated here. So if you want to get more information about Sqlc, you can actually go through this document and check it out. All right, so with that said, coming back into our code, we can create a new file called sqlc.yaml. And you have to stick with the YAML file because that's what it looks out for. So you might think YML and YAML are kind of the same, but in this case, they are not. So for Sqlc, you have to stick with YAML extension. So in here, we want to specify the version we want to work with. And the version is going to be 2. It used to be version 1, but now it's version 2. And here we can specify SQL. Then next, we specify the engine. And the engine in this case is Postgres SQL. Like that. Then next, you specify your schema. And your schema is going to be the directory to your migrations. So here we can have .db, specifying that we are within the same directory. Then the migrations. Then next, you can specify your queries. And this is going to be referencing to the new folder about queries we just created. So here we're going to have db, instead of migrations, we're going to have queries. Because it's going to read your queries and from there generate whatever Go requirement is needed. Then finally, we can specify a gen, which kind of signifies how the generation is going to work. So we want it to be a Go programming language. And since Go works with packages, we want the package name to be db. So here we can specify db as a package name. Then also we specify where we want our output to be. So that will be within the out. Then the same directory still, we have db, then sqlc. So that's what the folder I created is meant to do. Then finally, there are some configurations you can have that is going to help us. And the first one is emit empty slices. And what this does is, if you are trying to query users, for instance, if no users exist, it's going to return none instead of an empty array. So to make this happen, you can set this to true. Then also we will need a JSON representation because within Go, when you create your struct and you want to represent it in JSON, you will need a JSON representation. So with this parameter, whatever struct Sqlc creates is going to create a JSON representation for it, and that's the JSON tag. So I'm going to set this to true as well. All right, so we have our configuration ready. However, we don't have any queries at the moment. So we will need the query to be able to tell Sqlc how to work with our migrations and our query, okay? So again, we can come down here to read more about that. So this is what I just created, quite straightforward. Then this is what the query is going to look like. So we've handled the migration part, which involves creating the table and so on. Now we want to talk about doing the queries. And the queries is where you want to perform your CRUD operation, like list out the users, create users, delete users, and so on. So let's get started with that. So within our query, we are going to have query for our users operation. So users.sql, like that. So here you can specify the name. Just take note of the structure, it's quite important. So you can specify the name of what you want to do, and you can specify what the operation is going to look like. So in this case, get author means you want to get one information. List author means you want to list many authors. So whenever you specify one means you are returning one value. And whenever you specify many means you are returning many value. However, when you specify exec, it means you are returning no value, even though you perform an execution. Okay? So that's noted. So name, we want to create a user. And after creating a user, we are going to return that user, which is going to be 1. So again, this is where your SQL comes in. So if you're not very good with SQL, I guess this is a chance for you to actually learn it and use it. So here we want to insert into users table. So that's the name of the table. We can confirm by clicking here, users. So we can close this. Then you can specify the information. So the information we want to be able to send into the user includes the email, the hashed password. Then I think that's all. The created ads and the updated ads are going to come by default. So yeah, I think we are done with all the fields we need to provide. Then comes the value. So the value are going to be represented as a variable respectively. So respectively means $1 for email, then $2 for hashed password. Like that. Then finally, we can specify returning everything. That's that. So yeah, this is the query to create a user, and it's going to return that user we've created. So we're going to specify the email address as well as the hashed password. So also we can go ahead and create the other queries. So for instance, we want to be able to get a single user by its ID. So the name for this is going to be get user by ID. So again, it's going to return 1. And here we're going to have select star from users, where ID is equals to $1. Okay? So again, we can have limiting in the case maybe we just want to return 1 item, but we are certain here that this is only going to return 1 item because the ID is going to be unique. Okay? It's a serialized ID, so it's going to be unique. And with that, we are good. So always ensure you close your line. Then we can have another query for name get user by email, also 1. So the same thing, select star from users, where email is $1. Again, we don't need to specify a limiting factor because the email is unique, so we only expect 1 item here. So now that I have my queries defined, I have my migrations in place, we can do Sqlc. Remember, you have to install this, generate. All right, so it looks like we made a mistake with our config. So this should be tags, not tag. Okay, so with that corrected, let's try it again. All right, so it looks like there is an error with our queries SQL. Let's confirm that. Okay, looks like we don't need a comma here. I think that was the error. Okay, that's corrected again. Let's try it again. Okay, invalid query comments. I think I see where this error is coming from. So there shouldn't be any space with this. It's an operation. So yeah, that came out by default automatically while typing. So So let's try it again now. Oh, okay, I didn't save this. Save, clear, and try again. All right, so that was our error, and now it's fixed. And as you can see, we ran this without any issues, which signifies that the operation was successful. So if we open up this, we get to see all this theory information created for us. So we have the DB Go. So let's close our terminal. Yeah, let's not worry about this yet. So we have this information created to us by Sqlc, and we don't need to worry about this as well for now. Then we have models. And because we specified, so if we come back to the Sqlc YAML file, and because we specified this emit JSON tags, that's why we get this JSON information wherever we have our structs. Then finally, we have the user. All right, so we are having issues with our package DB or whatever information. And the way to fix this is by coming back to our terminal, and we can just say go mod init. Then we specify the name of our project. So in this case, we are working with FinGreat. The pattern of naming for Go goes like this. You have your source control. It can be GitLab, it can be GitHub. So in this case, it's going to be GitHub / your name Adefemi Great. Or rather, I think it's just Adefemi. Then the name of the projects, in this case, is the FinGreat DB. So I can have this as FinGreat _ DB or backend, like that. Okay, and as you can see, once I did that, it kind of removed all the error because, so the issue before was that it couldn't recognize this as a Go project, even though we have main.go. But now that we've initialized the project as a Go project, now it recognizes it and corrected all its error. So now this is recognized as package DB without any error line and so on. And here is our user operation. So technically we were meant to create this by ourselves, but with the query we specified, it's able to generate this for us. And we are going to need this information later on. Okay. So I will go ahead and define my other queries, like queries for updating the hashed password, query for deleting a user, and so on. Okay. And I think those are just the two other queries I would need. So let me quickly do those. All right, so here are the rest of my queries. I have one to list out all users, and the operation here is many. And the query is quite straightforward. So let's start from users, order by ID, and I am specifying a limit and offset information here to be able to paginate our data. Then I have the one to update the user password because that's what it does. It updates the hashed password. So for a situation where we have to reset password, then we can use this query. Then finally, I have the one to delete a user, which is quite straightforward. And once I've written those new ones, I can just type in SQL generate, and it's going to generate the updates. So now if we come back to the users.sql.go, we are going to have information about the new queries. So we have the list users, we have the update user password, okay? So again, we can come to our makefile. Instead of typing Sqlc generate, we can just have Sqlc. And here we can have Sqlc generate. And now we can come back to our terminal and just say make Sqlc, and it's going to run it. Okay. So the next thing we want to do now is to actually test to see if all these operations are actually working. Okay, so we want to be able to create a user, we want to be able to list out our users, and so on. However, we don't have an interface, that's our API, to actually test this. So what we want to do instead is to write unit tests to test these operations. So again, we are going to converge after taking this few minutes break. All right, guys, welcome back. So let's continue with our flow. So like I said, we are going to write our tests. And technically with GoLang, you are meant to write your tests where it's needed. So for instance, I want to test the user's operation, and based on that, I'm meant to write my test within Sqlc. However, after working with Go for a while, I realized it's much more tidy to have it within its own folder. However, the folder is going to be peculiar to where it is needed. And based on that, I'm going to have a folder within the DB for my tests. Like that. So in here, I want to have the user tests and so on. But to execute my tests, I want to perform an operation of setting up my DB and connecting to it. And I don't want to do this in every of my tests. So instead, I'm going to have a main test that is going to execute before any other test. And I can do that by just creating a new file and call this main_tests.group. So this package is still going to be within the DB package. So I can call this package DB like that. Then in here, I want to have a function called tests main. And as you can see, it's making two suggestions, either a single test or your main test. So I'm going to go with the main test because I want to execute this as the main test. So this is showing error because it requires me to import the testing package. So I can have a quick fix and import testing like that. So in here, I want to be able to set up my database and do all the things I need to do. And to set up a database, we can use the SQL package. So we can have SQL and it's going to import it automatically, .open. So here we're going to specify the driver name, which can be MySQL, Postgres, and so on. In our own case, it's going to be Postgres. And I can just type it, Postgres, like that. Then also, I will have to specify the URL, the location of the database. And we've used this already. So if we come back to our make file, this is the Postgres URL. So we can copy everything here up to the SSL mode and come back here and paste. So this is what we need to create a DB connection. So after doing this, we can associate it with a connection. Then there is a possibility of an error. Okay, so we use this to represent assignment and definition of variable in GoLang. So what I'm saying here is this as a function returns two information. It either returns a connection or it returns an error. Each of this information has their data type, okay? So what I'm doing here is that I'm creating this variable, I'm creating this as well, and I'm assigning the information from the return, both the value and the data type to this stuff. So that's what it's doing here. And in Go, if you are familiar with it already, you will have seen the check for error is not nil. So something like this. And this is just telling us, okay, if error is not nil, then you shouldn't perform whatever operation you want to perform. Or let the user know that, okay, there is an issue. And here what I want to specify is a log information. And I want to say this is a fatal situation. And I will tell it that could not connect to DB, to database. Then I will return the error itself. Then I'll close that. Then once I have the connection to my DB, I want to create a store relationship. Because if I come back to my DB here, I need to be able to create a store relationship which performs all these actions. Okay? So it's within these store relationships that I can perform every operation within here. So if you see, so this is going to even serve as an opportunity to talk about some concept of GoLang. Okay? So we have db.go here, which is defining most of the information about our DB. Then we have this query struct. And this query struct has information about our DB. And the DB itself is of type interface, which can perform these functions. So it can execute a contest, it can prepare a contest, it can query a contest, and it can query row contest. And as the name suggests, this prepare kinds of prepare our SQL query. Then executes the query. So query that doesn't return something, you execute it. Then query is to query information. Then query row is to query row information. So as the name implies, This is an interface that does all those information. And if we don't know what an interface is, so an interface is just saying that for whatever object that is going to implement that interface, it must perform these operations, okay? So now we have a struct here called queries, and the type is of this interface. So it means our DB implementation here, this connection is going to return a connection that performs all this interface, okay? So now before we can work with our users query, if we go into the users.sql, we can see the queries here. You see that the queries is associated with all the functions. So if we come back to the db.go, this query is associated with all this function. And this is like a class relationship in Go. So in your normal ORM programming language, you can create a class. And after creating the class, you can extend it to be used somewhere else, okay? So in this case, this is exactly what that is doing. So I have this struct, and the funny thing about Go is that you can actually extend almost anything. So I have this query struct, which I want to associate every query information with. And here I want to associate the get user by ID with that query struct. And to do that, I can just define a function, specify the associator, then specify the name of the function, and carry on with whatever it does. So whenever I'm using this query struct, whenever this query struct is being used, since it's associated with all these queries, then it can be used with it. Okay? So that's just some concept with Go that is a bit tricky, but if you work along with it, you get to understand it better. So yeah, that's about that. So back in here, we want to create these new queries, okay? And to create one, we need to send the DB information. And remember, that is what we are obtaining from here. But because we want to be able to use these queries everywhere else, we would first create a variable for it. And I'll call this var test queries or test query, then of type queries, like that. All right, so I see an issue here, and the issue is saying that a package is limited to a folder. So remember, we've used DB within this folder. So let's say we were writing this test within here, then this DB as a package will have made sense. But since we are within a different folder, this DB does not work again. So instead, what we'll do is we'll name this DB tests. Okay? So the package is for DB tests. And with that, we can import other information with the package name. So the information we want to import here is the query struct, and we just want to point to it. We don't want to import it as a value. We're just pointing to that query struct. So here we're going to have db.queries, like that. And now we don't have any error again. So now we can say test query is equal to db.new. Then we send in the connection to it. So this is going to associate our test query with our DB connection, okay? So that means we can perform all this query while having access to the DB, okay? And I'm defining this variable here so that it can be accessible from every other file that uses this package. Another thing to note about GoLang is the case, okay? So for this, we have the first letter being a small letter case. And what that does is that this variable can only be accessed by every file that has access to this package. So it means every file that is within the test folder, okay? But if we want to access this variable from outside this test folder, then we would have to name this as capital letter. So that's another thing to note, okay? Then finally, if we are defining the variable within this function, then that variable would only be limited to this function, okay? So this variable is outside here because we want to access it from every other file within this folder. And it's small letter because we want to limit it to just this file. All right, so that's done. So finally, to actually execute the test, we can have os, we import it .exit, then m.run. Okay, so what this is saying is that exit the process once you are done running your tests. So this is all we need to set up to run our tests. But now we need to write the test itself. And let's do that. So we have user underscore tests.group. So again, this is going to be package db tests. And with that, we have access to the test query. And next, we can have function tests create user. So also the naming convention is important here. So this has to be tests create user. And that's the way Go is going to recognize it as a test case. So for this one, it's going to be testing.t, and that's because this is the test file itself and not the main test. So again, we have to import testing. Let's do that. And writing Go becomes this easy because of the extensions we've installed. So if you are finding it difficult to get all this helper, then it's because you've not installed the necessary extensions. All right, so to create a user, we need to define the arguments, and we can have that as, then we want to get information about the creating of user struct. So if we come back to the user SQL, if we locate the create user, we'll find out that this is the struct required to create a user, as you can see here. And this particular struct is associated with the db package. So to use it, we can say db.createUserParams. And here we can specify the params. So the first param is going to be the email. And we can just put some email there. So tests@example.com. There we can have the hashed password. So this is meant to be an hashed password. But for now, let's just see if we can create a user. So yeah, I'm just going to have secret for now. And we are cool. So next we want to actually perform the tests by calling on the test query, which we have access to because we are within the db test package. So remember, we created this here, and because we are using the same package, we have access to it. So test query.create user. So it's a function we don't have access to. And we're going to pass the context.background function as a parameter to it. Then also we're going to pass our arguments. And this is going to return two variables. We're going to have either a user or an error. So again, we can represent them as user, error, then we have this. So now we want to be able to make assertions. And to make assertions, we have a package for that. We are going to need the testify package. And to install it, all you just need to do is type in go get this. And as you can see, the name kinds of match the way we've initialized our project. So yeah, this is the package we want to get, and we'll click enter, and we'll go get what we need. And to confirm this, you can come to the go.mod file, and you see the packages you are using here. So here is the testify package. And once again, I want to copy this. I want to come back to my user tests, and I want to paste this here. So we have access to the testify package. However, there's a module within it we want to use, and that was the assert module. So we are going to reference it like this, and come here, we can now assert and say assert that no error was found when creating the user. So no error. So the first thing we pass is the testing context, which is T. Then we pass the error information. So if you're wondering where the testing context comes from, here is it. So yeah, we've been able to fulfill the first assertion that when we try to create the user, no error exists. Then next we can assert that we were actually able to create a user. So we can have this as not empty, T again, then the user, like that. Then finally, we can even go deeper and say assert equal, pass T, that the user email we obtain, so user.email, is the same thing as the argument.email. Then also we can assert the hashed password, so user hashed password is equivalent to the argument hashed password. Then also we can confirm that the created at time and the updated at time exists, and we can use assert within for those. So we can have assert dot within duration. We pass our time again, Then we have the user.created@. So the next value will be time.now, which is the current time. Then finally, we can have a delta duration, just like an error seconds. So here we can have 2 times time dot maybe microseconds, like that. So here we are trying to assert that the created act happen now, then within this split seconds, okay? Then also the same thing for the updated act, okay? And I think that's all we need for our assertion for now. So technically we can run our test with this, however, there is going to be an error. So let's run it and see what happens. All right, so as you can see, we failed our test, and that's because it doesn't recognize the postgres driver we've specified. So if we come back to the main tests, we specified progress as a driver here, however, it doesn't recognize it. And that's because we need to install another package to identify this. So again, we're going to come down here and have go get this package. So github.com/lib/pq. And this is the package that will recognize our Postgres driver. So I'll click enter and go get it. And that was fast, it got it already. So again, we're going to paste it here. However, the issue here is that Go kinds of clean up our code. So for instance, at the moment, we are not using this. Postgres, as seen here, is just a string. It's not associated with that particular package. So if we save this now, we can say that this is out and we are still going to have our error. But that package is still required. So what we want to do is to import it generally, not in association with its usage. And to do that, we can have an underscore here and have the package itself like this. Okay. So now if we come back to our user tests and run the tests, so we have an error still. Yeah, so it looks like microseconds was too small. So yeah, we can just have this as seconds, and I think that should be okay. That's 2 seconds difference. Yeah, so the operation is happening on the database, so that's possible. And by the way, this has already created our user, and as a result of that, we won't be able to use this particular email again because it's meant to be unique. So if we come back to our database and refresh, you see that we have that user already. So technically our test was meant to be right, but because we didn't identify our assertions well, that's why we have the error. So what I'll do is I'll come back to my code and change this to 1 and save and run the test again. So this time around the test was successful, and that's because all our assertion passed successfully. So you must be wondering, are we going to be changing the value of email every time we are running our tests? Well, we are going to get to that later on. Also, currently our password is open. If we come back to the database, if we refresh, we can see our password, which is obviously not what we want. So again, we're going to take some break, relax, and refresh. And when we come back, we are going to undo how we can hash our password and how we can create random users so that we don't have to always specify a new email before we create a user. All right, guys, welcome back. So now that we are back, we have 2 major tasks to undo. The first one is being able to generate random emails, and the second one is to be able to hash our password before saving to our database. So now that we've mentioned that, let's create a new folder. And this folder is going to be outside our DB folder because it's going to be unique in its own way. I'll call this Utils. And within Utils, I want to have a new file called random.go. Also, I'm going to tag this as package Utils. Okay, so those are the first part. Now I want to have a function to generate random strings. So func and $string. So it takes in a parameter r, which specifies the length of string we are expected to generate, and it returns a random string. So in here, we want to define 2 variables, and I'm going to explain what they are going to do later on. So first, I'm going to have bits, And here I'm going to have an array of room, and I'm going to initialize it as an empty room. Then next, I'm going to have k for the length of alphabets. So we need to create alphabets. And here we can have variable alphabets of type string, which is just our alphabet from A to Z. And we're going to ignore any other extra character like numbers or capital letter. I think this would be enough. So here we can get the length of alphabets. Okay. All right, so before we proceed, let's quickly explain what this variable is going to do. So according to Go, a string can be also regarded as an array of characters. It means you can access individual character by their index. So technically, you can have alphabet of index 0, and that will give you A. However, when we want to represent characters like that, we can use rune to represent that. So rune is not just for character like we have with PHP. Rune is used to represent a single value. So it can be a letter, it can be a number, it can be anything. So you can use a rune to represent that. So now that that has been established, we are going to have an array of runes called bits. So now we're going to create a loop that is going to last the length of string we are meant to generate. So here I'm going to have for I, this and this. However, I'm going to change this from K to R. Okay? So this loop is going to last this length. So within here, we want to be able to get the index of the alphabet we want to get. And this is where the whole random thing comes in. So here we can have rand int k. And this is going to generate random number between this length. So it's going to start from 0 and end at 25 inclusive. So it's going to include 0 or 25. Okay? So we need to import this package. We can have a quick fix math.rand. Then now that we have this, we can store this character into our bits array. So bits equals to append. So we are appending into bits, and we're going to convert our character into a rune. So we have rune into alphabets, then the index. Okay. So after doing all this, we can return a converted rune. So we can convert the bits back to a string, like so. And there we have it, a random string generator. So we can even make this easier and have another function to generate random email. So we don't need to take in any information, but we are going to return a string. And this should be quite easy. We can just have return random string 8. So we always want the first part of the email to be 8 characters, then plus. We can have at example.com, and that should do it. So now if we come back to our user test, we can change this from the default to utils.random email, and that should be it. So next in line is our hashed password. And again, we are going to need an extra package for this. And the package we are going to need for this is from GoLang itself. And yeah, let's clear our terminal. And we can have go get golang.org/s/crypto. Okay, so that's the package we need to be able to hash our password. And once we have this package, hashing our password is actually very easy. So again, we can come back to our utils, create a new file, and call this password.grow. Again, I'm going to associate this with the utils package. Then I'm going to create 2 functions. One to generate an hash password, and the other to verify the password. So yeah, let's add the function. And one thing you should know by now is the character casing. So whenever we are creating a variable or a function that we want to use elsewhere, it has to start with capital letter. However, if you want to use that variable within just that folder, then it can be small letter. Okay? So to generate the hash password is going to require the password itself, and it's going to return an error or a string. So we can have a string or an error. Okay. Then here we want to make use of the package we just installed. Let's import it first. Import this. Then within our function, we want to have bcrypt. So bcrypt is within that package. Then generate from password. Okay. So as you can see, this is what the function looks like. It's going to take a password as array of bytes, and it's going to take in the costs. Okay. So the cost can be different thing, but we are going to use the default cost anyways. So the first thing we want to do is to convert our password string to an array of bytes. So here we have array of bytes, and we specify our password within it. Then next, we want to specify the cost in which we want to use the default cost for. So again, we're going to have bcrypt, then the default costs. And in all this, we are going to return two variables. It's either going to be the hash or an error. And as you can see here, the hash also is going to be an array of bytes or an error. So yeah, let's have the hash, then an error, then we have this. So we can check if error exists. So if error is not nil, you can just return. So it's going to figure out itself. Then next, we can return an hash converted to a string. So it's complaining because it's unable to recognize things. So one way to handle this better is, we can say this is going to be age of string, and this is error of error. And this is going to recognize everything. As you can see, there is no longer any error. Okay? But yeah, this is not going to be necessary. We can just revert things back to the way it was. And here we're going to specify it like this, which makes more sense. All right, so this is the function to generate an hash password. Now we need a function to be able to verify our password. Again, it's going to be quite straightforward. So we have function verify password. So it's going to take in the password we're trying to verify as long as the hashed password. So since both of them are going to be strings, we can combine them together. So we can have password, hashed password of type string. So those are some of the concepts in GoLang. And for this, we are only going to return an error if it exists. So again, to verify, we can check bcrypt. So bcrypt dot compare hashed password, and it's going to take a conversion of those passwords. So bytes, convert the password. So take note, the hashed password is going to be the first value. So let's verify. So as you can see, the hashed password has to be the first value. So don't just place any of the value here. So we're going to have the hashed password here. Then we are going to have the conversion for the second one here. And also this is going to return an error, just an error, nothing else. So we can check if error is not nil, return error. Or better still, we can just return error. So it could be nil. So that's okay. All right, so we have our two functions here. And now if we come back to our user tests, instead of having the secret here, we can just have this as utils dot generate hash password. Okay. And also, instead of just using secret, which we can also use utils dot random string, and we can specify the length of our random password. Like I say 8. Oh, okay. I think I see an issue here. So this is expecting both an error and an hash password. So we probably want to come out here and say hashed password that is equals to all this. So that means we also want to check for error here. So finally, this is going to have the hashed password. So in here, we can say if error is not nil, then we can log an issue. So log fatal, unable to generate hash password, then we specify the error. All right, so looks like we've handled the two situations now. So let's run our tests. So seems like our test was run successfully. So let's open Table Plus and see what we have. All right, so here is our hashed password. And if we pull this out, here is our randomized email address. So let's try to run the test again. So as you can see, it's cached. And that's something to note. And the major reason why it's cached is because it has not noticed any change. So it's expecting the same results. Okay. So what we can do instead is we can just run the package tests, and it's going to run every package tests. So also it's going to give us the coverage. And as you can see, everything is still okay. And if we check again and refresh, now we have a new user. So let's do it again. Run the package tests. Again, we have a new user. All right, so it looks like we are able to create a user. So it seems like creating a user is working the way we want. So our next line of action is to test updating a user or any other test. So let's go for updating a user. And in this case, we want to update the user password. So even though our test create user is working, a better test to actually have is a more unit test. So we should actually go in further into the utils and test all these functions. So we should be able to write tests to generate the password, write tests to verify that the password we generated is actually working, then write tests to verify that these random strings work. So yeah, we can write tests for those, but I don't want to bore us with that. So instead, we just focus on writing more tests for our users. So now this is testing create users, okay? However, how do we test that the email address is actually unique? So all I have to do here is just create a new user with the same information. So the email address should still retain. And here we can just copy this. And I'll call this user 2. And yeah, I'm specifying the same information again. So now our assertion should be that assert dot error. So error should exist. We specify our testing, then we specify the error. Then also we should assert that user 2 is empty. So empty, then testing, then user 2. Like that. So that's all we need to do for this, and I think that should cover that test. So we expect that this user already exists. So whenever we try to create that same user, it should return an error. And the user information for 2 should not exist. So let's run the tests. It should be successful. Yeah, and that was successful. All right, cool. So let's write the test to update a user. And like I said, what we want to update in a user is just the password. So here we're going to have func test update user. So before we can update a user, we need to create a user, okay? And it won't make sense to be rewriting all this. So instead, I'm going to create a function to just create a random user. So func create random user. And this is going to take in the testing. So I'll just copy this and paste here. Now copy everything from here and paste here, like that. So it means it's going to return something. So I want it to return the DB user like that. So finally, it means after performing every operation, we can return the user like that. Yeah, this has to be a pointer, so and user. So it's a pointer to the user. I don't think that's what we want. So instead, we want the real value, which is the user. And yeah, I think we are cool with that. So here we can have user 1 into this. And this is going to be create random user. And we're going to have testing T. So that means we need to generate a new argument for this. And that should be relatively easy. You can just copy this and paste here. So the email is going to be user1.email, and the password is going to be user1.password. It could be anything though. Okay, so we still have the same results, but now it's more cleaner. And now if we want to test for update user, we can do create random user and call that as a function. So we don't really need to take in. So now we want to try to update our user. So we can create a new argument for our user updates. It's going to be db.updateUserPassword params. So you can see the advantage of Sqlc here. So we can't pass more than the required params. So here we're going to have the hashed password. That means we have to create a password. Then we're going to have the ID of the user we want to update. So let's first get the password, and we can do that by coming here. So we can call this hashed password or new password. So I prefer new password. So also we need to copy this to verify that we are able to generate the password. So this is going to be the new password. Then here we are going to need access to the user. So we can get that here. And here we can have the ID as user.id. Now finally we can have new user, then error. Then we can have test queries. Test query dot update user password. So again, this is going to take context.background. Then it's going to take our arguments. Now we can start asserting. So I'll just copy the assertions from here. So we are certain that there is no error. We are certain that the new user is not empty. Next, we can compare the password. So we're expecting the password for the user to be the latest password we just updated. So here we can copy this. So user hashed password is going to be the argument.hashed password, or rather new user. We are using new user. Okay. Then also we can confirm that the user email is the same thing as the old user email, so nothing changed. So we have the user.email is the same as the new user.email. Now we have an issue because with our definition, the updated at actually just creates an update. It doesn't really update anything. So it means if we come back to our users SQL here, we have one more information to update for our update user password. So we have set hashed password to this. Then we also have comma updated at. And that will be true. So that means we have to update this to theory. All right, so that's an update we have to make. So now we can open our terminal and do make Sqlc. And that's going to update everything. So now if we come back to our user tests, we'll find out that we can now have the updated at field here. And this is going to be time.now. And that's all we need to do there. And with this, we are going to have the updated at field updated. So now that we've done that, we can now compare that the updated at is within our latest duration. So here is the test for our user updates, and let's run it. And as we can see, that's working as well. So let's run all our tests. Okay, so all our tests seems to be working. Let's see what we have here. And as you can see, we are getting random users every time and everything seems to be working. So we literally need to test all our queries. So we've been able to test create users. We've been able to update user. However, we need to be able to test for get user by ID, test for get user by email, test for list users, where we'll be testing for our limits, and test for delete user. So now I'm going to take a break and I will leave us to see if we can handle the rest of the tests. And while we are at it, I would also write my own, which I'll agree to share with us after the break. Alright guys, welcome back. So while we are away and I believe writing our own tests, I also went ahead to write my test as well. And based on that, I was able to create the following tests: test get user by ID, test get user by email, test delete user. However, I intentionally neglected one, which is the test list user. So I thought I would use this opportunity to show you one of the most important benefits of using GoLang, okay? And before we dive into that, let's quickly take a look at what we have. So this function is to test user by ID, and the requirement for this is to provide your user ID, which is of type int64. And the benefit you get with this is that you can't even provide any other information aside for this. So you can't provide an email. It's not going to be a valid type. An email type is going to be of type string. So this is something you get by having a typed programming language, okay? So I'll revert it back to the ID, and it means I can just test for email and so on. So now let's write the test for listing out users. And it's going to be quite straightforward at first, but you're going to see the twist later on. So we're going to have func test list user. So it's going to be testing T, and we have this. So compared to us just creating a single user here, we are going to create multiple users at a time. So here I want to have for I equals to 0, I less than 10, then I plus plus. So we want to create 10 random users. So we can have create random users and specify T. So here we can have our arguments and we can just have arg, which is equals to db.listUserParams. And here we're going to have an offset. And our offset is going to be from 0 to 10. Then our limit is going to be 10. So it means it's going to start from 0 to 9. So that's literally the whole idea. And now we can have users, then error into test query dot list users. So I just have context dot background here. Then we can have our arguments. So first thing first is to check that there is no error. Okay, so we're checking that there is no error, and we're also checking that the users are not empty. And technically, that's all we need to check in this regards. So the next thing we want to check is that the length of the users we are getting here is actually equals to 10. And we can do that by having assert.equals. Then we have T. Then we have length of users is equals to 10. So that's the expectation. So let's run this test and see what it gives us. So you see that the time it takes to execute does not really make any difference. It doesn't really feel so special. However, if we increase this to, let's say 30, let's work with 30 for now. And let's change this to 30 as well. That means we are limiting 30. It means we want 30 records at a time. Then we can increase this to 30 as well. Then we can execute this test again. And this time around, you can find out that it took some time. So it took 3 seconds here. And this is where you can introduce the power of concurrency, okay? So let's make this a concurrent operation. So the way to do this is just by saying go func. So we are going to create a function, and within that function, we are going to specify this there. And what we want to do is we want to call this function immediately, okay? So that's what we are doing. So this is going to execute this in a concurrent situation, and you find out that this is going to be faster. However, our test is going to fail. And that's because while we are making this test, most of this does not exist. So technically our test will not fail because we have users on our DB. So let's execute our test again, run tests. So as you can see, the time is faster now and it's not failing. And the reason why it's not failing is because we have users on our DB. So one thing I want to do though is for every operation we perform on the users, I want to delete it once I'm done. So here I can have a user cleanup. So func cleanup. Since we are within the user test, then we can just work with a cleanup. And from my cleanup, I'm going to have an extra query. So as you can see, our delete is only deleting where there is a user ID. What if I want to delete all from users? So I can do that by just saying, just from here, dash name, delete all users. So here we're just going to have delete from users. And that will be all. So yeah, let's come back here and make Sqlc. And that's generated. So now for our cleanup, all we have to do is have error. And here we're going to have test query dot delete all users. And we're going to have context dot background. And that's all we're having. And here we can check if there is an error. So if error is not new, then we can log a fatal error. And that will be all. So now for every time we create a user, we want to defer this operation. So I won't do this within this function. Instead, I'm going to do this within the test cases. So I can just call this defer. And this is also an opportunity to showcase what this defer does. So defer cleanup. So what this does is whenever this function is called, before going back to whoever calls it, is going to call this defer function. Okay? So let's say I call this function from the main test. Before it returns back to the main test, it's going to call this function. So it's going to call this function at the end of everything. And that's all we want. So for every operation we are performing, I'm going to call this function. All right, so let's run our test once more. So let's run all package tests. Okay, so we are going to have a failed test at 138. Let's go look at where that is. Yep, I guessed right. So we're having this failed test at this point. And this is because this is a Goroutine call. It means it's executing in a separate thread, different from our project. So this is what we term event loop in JavaScript. But in this case, this is the real thing. In case of JavaScript, your program runs within a single thread. It just tends to create a different event loop to run your async process. But in the case of Go, it actually creates a new thread and executes your Goroutines. So these are called Goroutines. And because the process you're executing here is required for you to perform this operation, you need to be able to wait for this operation to complete. And if you're familiar with JavaScript, we can achieve this by using async and await. Well, fortunately, we have the same situation here in Go. So you can achieve the same thing by defining a wait group. So here I can have var wg, and it's going to be sync wait group. So we need to import this sync package. It's within Go already. Okay, so this is what you need to define. And within your Go function, you can defer this wait group done. So just like you deferred within this function, you also define here. So you're literally saying that after performing your operation within your Goroutine, it should signify this wait group that it is done. And that's what it's doing. So when every of the wait groups are done, then we can then perform our operation. So here we want to have wg.wait, just like you have await within your JavaScript. So this is going to wait for every wait group to be done before coming here. So at that point, it means it has performed all its operation and we can perform what we want to perform here. And now actually testing this limit and offset makes more sense because If I get into this test case, then our initial users no longer exist. So we are only going to work with this. So we're expecting this to actually work. So yeah, let's run tests. So we are still failing. So let's see. Actually, I think I made a mistake with my code. So as we can see here, we are calling the old loop within this grow function, and reverse should actually be the case. So let's remove this out. So we should be calling this function itself within a Goroutine. So we are going to copy out all this, then have the Goroutine. So we have GoFunc. So within here, we're going to specify this. And now after everything, we can have this. Yeah, this makes more sense. And also another thing we are missing is we just specified done here. We didn't actually add our loop to the wait group. So here, this should actually be wg.add whatever concurrency we want to generate. So once we are done with that concurrency, we can say it's done and we wait for it. So by default, this is going to run within our normal flow. And with that, the wait group is able to know the number of concurrency it has to wait for. And once all those concurrency is done, it's going to signify the wait group that it's done and everything will be okay. Okay, so I think that was what we are missing. So let's run the test again. All right, so it looks like I figured out my error. So this should be 1. It looks like 1 actually. So it should not be I, but 1. So whenever we are adding to the wait group, we're adding just 1. And based on that, let's run our test again. All right, so as you can see, our test now seems to be running well. Okay. And this happened within just 1.2 seconds compared to if we were not using the Goroutine. So just again, let's confirm that. So if we ignore all the Goroutine and if we ignore all the Goroutine, all this information, and we just went ahead to execute this, we find out that it's going to take longer. So as you can see, it executed in 3 seconds. Not too much, and you're not taking note of that because, well, 30 is just very fast execution. Also, the database connection is close, so it's going to be fast. However, we're able to get better improvement with using Goroutine. And with that, we're able to run this. Okay, this is cached already. So let me just run everything. And that was fast. So everything executed within 1.6 seconds, which makes it cool. So if we go back to our DB and refresh, you'll find out that there's nothing. And that's what we actually want. So at the end of the day, we are going to be working with 2 different kinds of DB. We are going to have a local DB for our testing, and we are going to have our global DB for our real value. So on this note, we are done with anything relating to the user CRUD. So this is the user CRUD. We're able to create user, we're able to update user, we are able to delete user, and finally, we are able to list out users. So our next line of action now is to move on to our API because everything we are doing so far is just within the system. However, we want to be able to communicate to the external system through the API. So again, I would recommend we take a time off, relax, stretch your leg, and we assemble back to visit the API. All right, guys, welcome back. I hope we have enough time to reflect on what we've done so far. So now that we're back, we want to work on the API so that we can expose what we've been building so far to the world. Okay? So again, like we are familiar with already, I'm going to create a new folder and I'm going to call this API. And within this folder, I'm going to create a server file. So this is going to be the server file that serves our information. So here I'm going to create server.go. Okay. And I'm going to tag this package API. I think we should be familiar with that by now. So in order for us to actually achieve the aim of our API, we can use the default packages within Go to get things up and running. However, one thing I found out with the default package is that it's kind of low level and requires you to write a lot of code that really doesn't matter. So instead of going through that route, there are a lot of packages out there. There are a lot of frameworks out there that can make this even faster while still achieving the same aim. And the one I'm going to use for today is going to be Gin. All right, so let's go to the browser and see what Gin looks like. So this is the website for Gin, and with this framework, you have the opportunity to perform your routing, your middleware, and so on in a fast manner, okay? And the whole point of using framework in this case is to be able to carry out the same functionality you'll have done yourself in a very fast manner, okay? And Gin seems to actually be the easiest one from my experience, and that's why I'm going with it. I like to use easy things. And to install Gin, it's going to be quite straightforward. So if you come down to the documentation, quick start, you'll see how to install Gin. And I think by now you should be familiar with this. We've been installing a lot of packages since. So I'll copy this, come back to my code, open my terminal, and paste. So this is going to run things and install Gin, and now we've installed Gin. So how do we set up a server? So setting up a server is actually straightforward, and let's demonstrate it. So we can have a function for new server. And because we are going to make a call to this new server function from our main.go file, we are going to pass the port we are using. So the port is going to be an integer. So to create a new server using Gin, all we just have to do is have something like G, short for Gin server, then equals to Gin.default. Then next you can have Gin.run, then the port you specified. So we have to convert that port to a string. And we can do that by having fmt, then sprintf, then we are going to have the structure, so dot. So technically what we want to have is something like, so let's ignore this for now. So what we want to have is g.run into this structure, then we have the port in front of it like this. But since we are sending the port as a parameter, we want to be able to place it within this structure. And that's where this comes in. So here this is going to be %v as the value, then comma port, like that. So with this, we can run the server. However, we don't have any route yet. So it's just going to run the server without any route to listen to. And to easily do that, we can have g.get, then we can specify the path, and the path here can just be the default path. Then we are going to have a function like this, func, that takes in the Gin context, and we can perform whatever we want to perform. So if we want to return a JSON format, we can as well just do cts.json into. So you're going to specify the code. It can be an error code, it can be a good code. In this case, we are going to use the 200 good code, then the objects. And to represent your objects, you can use gin.ish, like that. Then you specify your objects, and here I can have message and have welcome to FinGreat. Okay. So now we have this function we can call to start our server. And now we can come back to the main.go. And instead of just printing this, we can have API.new server. And we'll specify the port we want to use. In this case, the port is going to be 3000. And that's all we need to do. So if we come back to our go.mod, we'll see that there are a lot of untidy stuff going around here. So a lot of indirect and stuff. And the way to tidy this up is by saying go mod tidy. So it's going to run through things and tidy it up. So as you can see, it has tidied things up. From here, we can tell that these are the major package we require. However, since this package also needs some requirements, then they can fall within the other required package. So yeah, let's actually test our server to see if it's actually working. So we can clear this. To run our server, we can have go run main.go. Okay, so as you can see, we have this output. And when you are using Gin, it gives you information about the route you have available. So we have get / and it's linking to this function. So to test this, we can pull up our Postman, or we can run it directly because it's still going to run directly. So let's start by running it directly. So if we go to localhost 3000, yeah, we have this because it's a JSON. But this is not where we want to be running it. We want to run it through our Postman. So here is Postman, and I believe everybody should be aware of this. It's a tool we use to test our API endpoints. And here we can specify the endpoint we want to use. Localhost 3000. And that's all. That's the default path. And currently we've only registered a get method for this path. So if I send this, we are going to get these results in JSON format and our status code here. So there we have it. We've set up a server, which is quite straightforward. So before we proceed, one thing you'll find out with other programming languages and tools like Django, Express is that whenever you make changes, you can auth reload your server without having to start the server again. So fortunately, you can also do the same thing with Go, and it's quite straightforward. So let's get into that. So the tool we will need to achieve that is called compile daemon. So let me just go to the browser and show us what it looks like. So compile daemon, very simple compile daemon for Go. So you can just go through this to see what it looks like. So one thing I expressed when trying to use compile daemon is that using it is actually not straightforward. So from here, you find out that to use it, they ask you to do go get compile daemon. However, that's not all you have to do. So you can have go get compile daemon to kind of register it as your packages. But to actually use it, you want to copy this, come back here. So we can paste this for now and get compile daemon. Then also we want to install it into our local machine. Okay. So to do that, we'll change this from get to install. So I wrote install instead of install. Okay. So this is going to reinstall the executable, and now you can actually access compile daemon within your terminal, which is what you need. And once you can do that, we can then say compile daemon, then dash command. Then we specify the location of the project you are working on. In this case, the project is backend. So here I'm going to have .backend. And I'm going to enter. So this is going to run the same project. Okay, there seems to be an issue. No directory, no such directory. So the mistake I made is me not recognizing the name of my project. So the name of the project is actually not backend, but FinGreat backend. So take note of that. So I'm just realizing that myself now. So I can remove this. It was generated by the compile daemon. So now we can try it again. Compile daemon, then dash command, then equals to / the name of the project, in this case FinGreat _ backend. All right, so now it's running the server, and whatever change we make to our system is going to refresh it. So let's change this to welcome FinGreat, then exclamation mark. So let's save it. You see that it restarted the server automatically. So if we come back to the Postman and run this again, then we get the changes. So yeah, we have that now, and I think we should know the routine. So we can close this, come back to our make, and here we can have start. So yeah, we are starting the server. And to start our server, we are going to have compile daemon, then dash command equals to / then the name of the project, FinGreat _ package. Okay, so there we have it. We can clear this out and now do make start. All right, so now we still have the same thing. So we can leave the server running. I think it's okay. So currently we are able to start our server here, but that's just quite basic. It doesn't have enough information, because before we can start our server, we should have initialized our database and so on. Okay, but now all we just do is start the server. Also, we want to be able to control how we start the server and not just do this every time. So because of that, we are going to structure our server a little bit. So first we are going to create a type of struct for the server. So this is going to be server of type struct. So first, our server is going to have reference to our queries, because remember, we are going to be able to communicate with our DB query using this query struct. So here we're going to have queries, and we're going to have reference to that query. So that will be db.queries, like that. And also, because I want to have access to the gin router itself, I can make a reference to the gin router. So here I'm going to have a router, which is just an instance of the gin engine. And I'm going to reference the gin engine itself, like that. So those are the two things I will need for now. So before we can make reference to this query, we have to initialize a DB, okay? And we've done that before. If we come back to our DB, come down to the tests, come down to the main.tests, we've done this already. This is technically the same thing we'll be doing again, and we'll be repeating all this content. So we want to avoid that. And I think we can guess already. We want to be able to get this information from our environment variable, okay? So as of now, I can think of two ways to do this. We can either use the Viper package. And if you are trying to work with strictly .env, then you probably are limited to just this. The Viper package will not work for .env, because the Viper package expects your env file to have a name, okay? But yeah, still I'm going to go with Viper, and here is the package for Viper. So if you want, you can go over this and see how it works. So yeah, I'm going to get Viper, come back to my code, install it. So I can stop the server for now. We don't need it. I can clear this. Then I can paste this. All right, so now we have Viper. And to actually initialize this process, I'm going to do it within the Utils, because then I can use it in other places. So here I'm going to have config.go, like that. And with Viper, like I said, you're going to structure what you need, okay? So first thing first, let's add the package utils. Then next, let's define the config structure, okay? So this is going to be type config struct. And for our config, we are going to need the DB driver. So here we're going to have DB driver. It's going to be of type string, and we want to map structure it to how it's going to be within our env file. So yeah, this is going to be map structure, then the key within our env file, and I think capitalizing this makes more sense. So DB_driver, okay? So we can do it for the other one, and there we have DB source. Again, this is going to be string, and the same thing like we have there. And we can close it. We don't need this comma. All right. So we have the two keys we would need. So the next thing is to actually load the config. So here we're going to have a function to load the config. And again, this is going to be capital letter because we want to use it somewhere else. So we're going to specify the part of our config, which is going to be part string. So technically, we are meant to get this part from wherever is making a call to this function. So if we are calling this particular function from main, then that means the part is going to come from reference to the main. So that's something you should know. So when we are using it, we get to see that in action. So in here, we want to add viper.add_config parts. Then we can specify the path we've provided. Then Viper .set config name. So this is where I'm saying that your config file needs to have a name. So you can't just use .env in this case. So if you are strictly going to use .env, then I will advise you use the good.env. So for my env, I'm going to have env. So env.env, and I think that's cool. Then finally, because we can work with different env file type, we can work with .env, we can work with .json, we can work with .yaml, and so on. So also we need to specify the type for our env. So we can have here viper.set config type, like that. And this is going to be .env. So again, we're going to have that. Then Viper has the ability to automatically load the env from your local machine. So in the case where you have export env key, then env name, then Viper takes precedence of that over the one you have within your file. So to config that, you can say viper.automatic env, like that. So this is going to load the env you have within your machine first before considering the one you have in your file. Then finally, once you have done the automatic env, you want to read the config from your file into your system. So to do that, we can have error into viper.reading config. Then if error is not nil, so if error is not nil, we can return nil and error. So yeah, we need to specify this like this. Then also we want to unmarshal the content we've read into the config we've defined. So based on that, we might have to specify a variable name here, config, and that means we need to specify error here. So based on that, we don't need to define the error again. We can just say it's equals to this. So now coming back here, we can say error. If there's an error when unmarshalling, viper.unmarshal, then we bind it to the config variable. So config. So that's why we define the variable name. Then again, if there's an error, we can return nil and that error. Else, we can return the config and nil. So there's no error in this case. All right, so that's all we need to do to initialize our config. And this is what it looks like. Quite straightforward. So now we have to define our config based on what we've set here. So here I'm going to create a new file and call it env.env. And if we come back to config, we want to make sure that it matches what we have here. So the DB driver and the DB source. So the DB driver is going to be Postgres, and the DB source is going to be what we have within our main.test. So let's just copy this. Yeah, so these are DB source. So if we come back to our server, we can ignore this for now. So now that we can get our information from the config, let's update our test first. So instead of upcoding them like this, we can get it from the config. So here we can have config, then error, because we are expecting both, equals to utils.load config. Then we want to specify the path. And like I said, since we are trying to reach the config from this function, then we are going to start reading our path from here. So yeah, this is here. We have to get out of tests, then get out of DB, then we'd have access to this env path. So that means we have to get out of tests, then slash get out of DB, and that's going to be the path. So here we can check if error is not nil. Then we can log fatal. Could not load env config. Okay. Then now that we have the config, we can change this to config.postgres, or rather DB driver. Then this will be DB source. Config.db source. Okay. So let's run our tests. And currently to run our test, we've had to go back to the user test and run package test. But a better way to do it is just open our terminal. We can just do go tests -v -cover. We are telling it to show the coverage. Then if we just specify /..., then we are telling it to run tests for all our files. So if we click this, it's going to run all our tests. And as you can see, there is no issue. All our tests passed. So it's complaining that we don't have tests for this, we don't have tests for this, and that's okay. So like you know, we don't want to keep typing that every time. So we can clear this and just copy this. And come back to our make file and come down here and specify tests and specify our command. So now if we want to run our test, we can just do make tests. And yeah, because it's charged, everything seems to just come back like they were before. So we are good with this. It shows that the config was loaded successfully. So now we were trying to set up something before we had to introduce config. So here, like I said, we want to initialize a DB again. So to do that, we need to load our config first. We can copy that from here. So config, just copy everything we have here. Come back to our server, paste, and we can import the Utils package. And we can import our log package. So instead of printing log package, because we are not actually running on os.exit like we were doing with main, as you can see here, we are actually going to panic, okay? Panic is like saying we want to shut down the whole system and tell us what happened, okay? So we don't want to go any further. So here we're going to have panic. All right, so panic like this, and now we don't have to use the log. So next we want to initialize our DB. We can come back to our main and copy this whole thing. Come back to the server and paste this here. So this is going to be the DB connection. And here again, we're going to have panic. And we can remove this error of contents. And we need to import the SQL here. So now for these queries, we need to initialize it. So here we can have q equals to db.new. So you have this information within here. So remember we have this information and we can specify the con to it. So this is going to be colon then new db. Then next we want to remove all this instead of having that. So now our new server is not just going to return nothing, it's going to return a pointer to the server struct. And here we can return the pointer. So server into this. Then our queries is going to be Q and our router is going to be G. So now to actually start the server, we can associate a function with our server struct. So here we can define a function that is associated with the server struct and call this start. And to start our server, we are going to need the port. So instead of having the port here, we need the path to our env. So path string, or let's just call this env path and change this to env path. Okay, so now since we have access to the server instance here, we can say s.router, which is the grouter.get. Then we can specify our path once more, our paths. Then we can specify the function. So again, we are going to have cts.json. Then we specify the code, which is 200. And a better way to specify the code is to use the HTTP package. HTTP package status OK. Then we can have the gin.ish. Then we specify the message. Then, like we used to have it, welcome to FinGreat. Like that. All right, so now we've adjusted our code a little bit. So when we come back to the main.go, this is not expecting an integer any longer, it's expecting a string. And here we can have server equals to this. And the path for our env now is going to be the default path here. So you guessed it, it should be just dot. And here we can say server.start. Then we specify the port, which is going to be 3000. So back here, we can say make start. So we got the error could not connect to database. So let's figure out what the error is. And as you can see, the panic canceled all our process. All right, so the error looked strange to me at first, but later after digging, I was able to figure it out. So to actually better portray the error, instead of just saying could not connect to DB, let's also try to see what the error looks like. So here I'm going to change this to fmt.sprintf. So here we are going to have that string, then we have a colon, then we have the error. So I'm going to do the same thing to this. So we'll copy this, paste it here, change the text with what we have here. So it's always a good idea to see what the error looks like. All right, so now that we've done that, let's run the server again. All right, so as you can see, could not connect to the database, SQL unknown driver. And I think we've encountered this before. So if we come back to our main tests, we need to import this. So that's the fix for that. So we go back to the server, and we import this. Then if we start the server again, which I believe should have reloaded, now it is running well. So we can go to our postman and test the server again. Okay, that's not working like we want. So we have router this. Oh, okay. So we only set the router, we actually didn't start the server. So here we're going to have s.router.run. Then the server, and that's going to be fmt.sprintf. Then the port, so it's going to be dot, then %v, then the port. Okay, so the server is going to reload. Now we are running the server. We can come back here and execute this again, and we should get the same results. So yeah, I think we've covered a lot of things within this period, and I think it's time for us to take some break. So when we come back, we would actually implement the API endpoint for all the CRUD operations we've created so far. So yeah, let's go relax and come back later. All right, guys, welcome back once again. So now that we have our server up and running, the next thing is to be able to link our CRUD operation to our API such that we can access the CRUD operations through the API. And the way I'm going to approach this is I'm going to group the server into each resources. So what I mean by this is I'm going to have a new file here, and I'm going to call it user.go. So this is going to contain activities relating to the user, okay? And for this, I'm going to also tag it as API package. Then I'm going to create a user struct here, which is going to reference the server itself. So here I'm going to have the server as a pointer to the server. Okay. Then further to that, I can define the function to maintain the user's route. So here I can have func u referencing the user struct, then define a router for it. So the router is going to take the server pointer and it's not expected to return anything. So we're going to remove this. So what we want to do here is to point the server to the user struct. So here we can have u.server equals to the server we just sent. Then here we can create a server group for the user. So here we can have server group. which is equals to server.router.group. So remember, the server has the router instance within it, so we can just extend the router instance here. And also the server also contains the query, so we can use that to get information about our queries. So here we want to have the user group as users. So it means to access anything within the user group, we have to go through /users. Then lastly, we are supposed to have a middleware here, but we've not reached there yet, so let's ignore that. So after defining the server group, then we can associate endpoints to it. So here we can have server group .get, and here we want to be able to get the list of users. So I don't see a use case for this for the user side though. Probably it's going to be useful for an admin, but nonetheless, we are trying to create APIs, so let's have it as well. So we're going to create functions associated with this user struct. So we'll get to that later on, but for now, we are going to have a function called u.listUsers. Okay, so it's going to show this line because we don't have that function yet. Then also we are going to have server group.post, and this is going to be the process of creating a user. So here we're going to have the same endpoint. So if we don't include anything, it means that's the default endpoint. Then we are going to have u.createUser. All right, so that's all we need to do in terms of this. But to ensure that we have everything cleared out, we don't have any error, we have to define the functions we just specified. So again, we're going to have func that associates with the user. Then we have the createUser function. And since this is going to be a callback referencing the Gene controller, that means we have access to the context. So we can just represent that with C. Then have a pointer to Gene.context. So we are not expecting any return, so we are good with that. And that's the function to create user. Then let's quickly create a function to list users. So here we're going to have list users. And now we've satisfied the requirements here, so we're no longer getting the error. So the yellow line we are getting here is signifying that we've created all this without actually using them. So let's go back to the server to actually use it. So here we can instantiate the user struct like this, then call on the router function. Okay, so let's confirm this. Yeah, we have the router function. Then this router function takes the server. S is the server, if I can remember. Actually, I made a mistake. This instantiation should be just the user struct and not a pointer to it. So that should fix this error, as we can see. So now we've instantiated the user group, and if we check the server now, we'll find out that we now have the path for the users. So let's just do something for now. Let's return the users list. So here we can return the users list, and we can do that by just having users, then error, then we can have the u.server.queries.listUsers. So remember, listing out users requires your parameters. So here we can create that param. So we can have the ag, then we can have the db.listUserParams. So here we can specify the offset, which is going to be 0 by default, then the limit, which is going to be 10 by default. So it means we want to list out 10 users at a time. So here we're going to have context.background, then the argument. Then finally, we can return the users. So if there is an error, so if error is not nil, so this is most likely an internal server error, okay? Because if there is a syntax error, then our code will not even go through. So the only error that can occur at this point is going to be an internal server error. So as a result of that, we can have c.json, http status internal server, Then if we want, we can show out the error, or we can just use some kind of generic error. But I think I'll go with showing the error. So here we can have gin.ish. Then I can have error. Then error.error. So error.error will convert our error to a string format. Then finally, we can return c.json. So we can have http.okstatus. Then we can just return the users. And this is going to convert everything by itself. Because remember, the user struct contains the JSON information. So this is just going to convert things to JSON, and we have our results. So yeah, that was the implementation for that. However, if we come back to this and test this out, so we have access to the users, and if we click send, we don't get anything. And that's because every time we run our tests, it's going to delete error users. So on that note, the best way to go would be to have a separate database for the active content. And yeah, we can create a new database. We can come back to our docker compose.yaml file. So we have Postgres here. I will leave that. Then I can create another one. I'll call this Postgres Live. Okay. Then the container name is going to be FinGreat Postgres-live_live rather. Then we are going to have the same information as before. The only difference now is going to be with the ports. Okay. So every environment variable will be the same, but the port is going to be different. I'm going to change this to 5433. Okay, so that's cool. If we stop the server and restart it, it's going to pull this up. So we can come back to our make file. So make migration still work. Postgres up is going to run everything and start it up. Then db up. So we also want to run for the Postgres live. So we can have a second command. So the first one is going to create for our test DB, and the second one is going to create for our live DB. Okay, then the same thing for the down live DB. So migrate up, we are going to do the same thing. So this is going to be Postgres, the same thing. The only difference is going to be the ports, which is 5433 for the live version. So the same thing for this as well. 33. All right, so it looks like that's all we need to do. Okay, so we want to stop the existing server. And yeah, let's first stop this server. So next we can have make p down. So it's going to bring down the existing Postgres server. Now if we do p up, it's going to create two Postgres server. So as we can see, we have the regular Postgres server, which is going to be for our test, and we have the live Postgres server. So now the Postgres server is up. The next thing is to create the DB, and we can have make DB up. Okay, so as we can see, it has created DB for both the live server and the test server. Then next we want to run migration. So make up. All right, so the migration is up and successful as well. And yeah, I think that's all we need to do in that regards. So next thing is to define the DB source for the live version. So if we come back to our environment, so we can have that as DB source by default. Then here we can have DB source underscore live. And we are going to change the port to 5433. Save that. Now come back to our config.go. We have to include this. So DB source underscore live. Then here as well is going to be DB source underscore live. And we are good on that part. So coming to our server, we want to be getting content from our live DB. So yeah, so here where we are having the DB source, we are going to have DB source underscore live. And that looks good. So if we start the server once again, Okay, our server is still up and running, and if we try to get our users, we still get an empty user. So now we can create a user. So let's tackle that next. So coming back to our user, we have the function to create a user. So again, we are going to need the arguments, okay? And for the user, we want to create a user input struct, or more like a user body struct. So let's do that. We can have type user params. And you want to make it capital letter because you can use it somewhere else. So this is going to be struct. So for our params, we are expecting an email. And take note of the first letter capital. It's important too because we are going to be exporting it. So email is going to be of type string. Then we specify the JSON representation, which is going to be this. Okay. So if you use small letter, then you are going to have an issue. So the next one is going to be the password. So what we are actually requesting from the user is password and not hashed password. But what we are storing on our database is an hashed password. So that's something to take note of. Okay. So this is also an opportunity to introduce to us validation, because as it is now, we want to get email address and password. However, if we did not provide this information, then the process will still go through. There's no way to validate anything. And with Gin, you have validation out of the box. So the way to use it is by specifying binding here. And within your binding, you can specify the kind of validation you want. So in this case, I want the email to be required. And here I can specify required email. Then also, I want the email to be of type email. So again, I can say email should be email. Then the same thing for the password. I want to specify binding and I want it to be required. So it means before you can satisfy the create user function, you must provide all the requirements. Okay? So now we want to create a new user. And the way to do this is to have user, just a temporary variable, is equals to new. Then you can specify the user struct, which is going to be the user params. So it's going to create an instance from there. Another way you can do this is by saying var user, then user struct or user param struct. So you can either use any of the two. So whichever you're comfortable with, you can use. So next, I'll bind these params with our request body. So what it's going to try to do is going to look through the Gin request body and see if it conforms with the variable's requirements. So to do this, we can have c.should bind JSON. And this is what you want to use if you are trying to bind your body contents. Okay? So if you are trying to bind your JSON payload, this is what you want to use. Then you're going to provide the variable, which is user, and to actually signify that you are binding, you specify the and sign here. So this is going to return an error as a possibility. So we can have error equals to this. Then with GoLang, we can just do a single line checker. We can say if error exists after doing this bind. So that's what we just did there. So we checked if there is an error here. So we are now trying to test that error. So if the error actually exists, then we want to return a server error. And in this case, this is going to be a bad request error. So yeah, we can just copy what we have here. And we're going to change this to bad requests. So bad requests. And yeah, the error is going to be error.error. So after performing this operation, now we should have the content within our request body assigned to this variable. So the next thing we want to do is to generate our hashed password. So we can have hashed password, then an error. So here we can have utils dot generate hash password. So we're going to specify the password string, which is going to be user.password. And I think that's all we need. So again, we're going to check if error exists. So if Error is not new. In this case, this is going to be an internal server error because we are trying to convert it from our process. So yeah, we are going to have internal server error like that. So now that we have the hashed password and we also have access to the email, we can create our argument. So here we're going to have arguments or just add. Then here we're going to have db.createUserParams. So here we can specify the email as user.email. Then here we can have password, or rather hashed password as hashed password. So doing things this way has kind of prevented you from having any SQL injection because you know what you are specifying and nobody can just pass any information and it gets to your database. Okay? So next we can have the user, then error, which is going to be the u.server.queries.createUser. So this is going to take in the context.background, then your argument. So error has been defined already. Has user been defined? Yes. So here we can change this to new user. Okay. So the reason why error is not bringing out an issue is because the error is still the same thing. So there's no issue. But in the case of the user, you are trying to convert it from a variable type to another variable type, which is going to present an issue. And that's why we have the initial issue. So now this is our user, and we can return c.json into http.created. So in this case, we just created something, and we specified the new user. Okay, we don't need a return. All right, so this actually brings my attention to something. So when you have this within Gin, it might look like it's going to break your code here, but it's not. So it's still going to go further to do other things. So what you do after returning your error is to return out of the code. So it means whatever you do here, you want to return once you are done. The same thing here. Then finally, you don't have to return because it's going to return by default. So the same thing here, if there's an error, you want to return, and that will be good. Yeah, we want to check if there's an error here as well. So we can copy this and paste this here. So if there's an error creating a user, it's going to be an internal server error or probably a bad request. So there is two ways to it. So if the user exists, then it's not an internal server error, but a bad request. So we can check if it's a user already exists situation. In this case, we want to check the kind of error we are dealing with, okay? So here we can check if it's a PG error or it's okay. So we can cast the error into a type. So here we're going to have error dot. And error is regarded as an interface in this situation, okay? So let's just brush about that. Then we point to PG dot error. So if it's okay, in this case, if it's a PG error, that's what it's saying. So we are trying to match this error to this type. If when we try to match it was successful, then it's a PG error. So this is not PG but PQ. So PQ like that. All right. If we are able to successfully convert this error to this, then we can check the error code itself. So we can say if PG error dot code is equivalent to 23505, and this is a code for specifying that you've violated a unique constraint. So you can return your error. So in this case, this is going to be a bad request error, okay? However, any other error in this case would be an internal server error. So if there's an issue with your Postgres, then it's an issue from your side, not from the user. So here we can return this. So internal server, or rather bad requests, And we can say, so the unique constraint in this case is going to be the email. So you can specify user with user already exists. Yeah, something like that. Then else you can have your other error. So I can just have this error outside here. So once I'm done here, I'm going to return. Remember, once I'm done here too, I'm going to return. So whatever error we are going to have here is going to be an internal server error. So here I can have internal server error. And here I can change this to error.error, like that. And yeah, we are done with the operation. So let's see if this actually works. So if we come back to our browser, so we change this to a post and we send. So error end of file doesn't really ring a bell, but the whole idea here is that you didn't actually provide anybody, and as a result of that, it couldn't really read the request.body. So we undo that later on. It's really not an issue now. So let's go back to our body and specify a raw body of type JSON. So if you specify an empty JSON and send, oh, okay, I'm ready somewhere else entirely. So specify an empty JSON and send, then you can see user params email error field is required. So let's provide an email. So here I can just have me@example.com. And if I send again, it's not complaining of the password, and I don't think that should be the case. Let's confirm what's going on. Oh, okay. Here, we got the error. We didn't export this. So this should be capital letter. So let's try it again. So now the email already exists, but it won't even get to that. So let's send it again. Oh, looks like it got to that. What are we missing now? Okay, there seems to be an error, okay? Yeah. So the server didn't actually restart. It was just running the existing one. So yeah, let's do this again. So now it's complaining about the password being a required field. So for now, we can say that the way the error is being shown is not very intuitive, but we'll get to that later on. But as we can see, we get an idea of the validation working. So if I remove both fields, then I get the whole information provided. So now let me return the email address and provide a password. And we guessed it, the password is going to be secret, and we'll send. And now we get the user already exists, and this is the part of the unique email coming in. So this is a bad request and not an internal server error. So you want to be able to distinguish between the kind of errors you have. So however, if there is an error that happened not due to the user's request, then it's going to probably be an internal server error. So if we remove this example.com and just send me, let's see what it's going to look like. So as you can see, it's validating that email is invalid. Okay, so we have that. So let's try to send a different user now. So I'll have this as me1 and send. And as you can see, it has created that user. So as we can see, it's returning a hashed password, which is not what we want. The password should not be returned as a response. So that means we need to create a new struct for our user and convert our user. Okay. So here I can come down here and say type user response, or rather let's make capital user response struct. And here we are expecting every value of the user except for the hashed password. So we can come to the DB, come to the Sqlc, come to the models, and copy everything here. So come back here and paste. We are going to remove the hashed password. So we need to import this package, the time package. So next we want to create a function and associate it to the user response. So here we can have func to user response. So this is going to take in the DB users param. So we are going to have user of type db.user like that. And it's expected to return a user's response. So here we are going to return and user response into id user.id email user.email created at user.created at then updated at user.updated at. All right, so that's all we need to do. So to actually see this in action, we can come here. So instead of returning new user, we can say user response. We initialize it, then to user response. I will specify the new user there. Oh, that's wrong of me. This should be type user response. So yeah, we've seen this error before, and that's because we are pointing to this instead of just initializing it directly. And also look at the error we are getting here. So this should be a pointer to the new user. So what that means is when we send the parameter here, it's not going to create a new object. It's just going to point to the existing one. Okay. And I think we're good with that. So let's create a new user again. We can change this to me too. All right. So now we get the result back, but without the password, which makes more sense. Okay. So we are good with that. We can now list our users. So let's try to list the users again. So this is going to change to get. So we have how many users? 1, 2, 3. So we have 3 users. However, the issue here is still the same. We are still returning the hashed password here. I believe we guessed it. We can improve on that. So instead of returning users here, we can look through users and return our result. So here we can have new users of type slice of users response like that. So here we want to look through the existing users using the range method. And we can do this by having for index from our value into range users. Okay. Now we can append new users equals to append new users. So we want to create a new instance of the converted user. So we can just have this as n into, so we can copy what we have here and paste it here. And this is going to be v of the user. And now we can specify n here. So it's complaining about the user response being a pointer. So yeah, we can just make this a pointer as well. And it means we don't need the index. So we can just make this underscore. All right, so now we have new users here and we can return new users. Okay, so let's see this in action. So we are not expecting to get the hashed password again. So let's see. And yeah, there we have it, no hashed password. So now we can get our users and we get the results in the expected manner. So we have few other APIs to create. We can try to create an API to get users with email or get the users with the ID or try to update a user. And for the ID, we can use something like the URL param where we can extend the users and have something like ID here. But yeah, we won't bother about that for now. We're going to visit it later on. Let's proceed with the next line of action. And now we have a user. We can create a user. We can list our user. The next thing is to be able to log in with that user. And that's what we'll be visiting next after our break. So again, let's go and refresh and yeah, come back later on after we are done refreshing. Hello guys, welcome back. And that was our break. So now that we are back, let's continue from where we left off. So at the moment, we can create users, we can list out users. Also, we can update users. However, we want to be able to authenticate users, okay? And this brings us to the first part of our security, which is authentication. So now that we've created a user, we want to confirm if that user really exists before he can access our resources, okay? And for this to happen, we have to authenticate the user. And to perform this authentication, I'm going to create a new API, and I'm going to call this Auth. So here we are going to have every activities that has to do with the Auth. So just like we have with the users, we can just copy the structure we have with the user. So here we have the user struct, we have the user, we can copy this and paste it here within the auth.go file. However, before we do that, let's tag this with a package. So package API, then we paste this. So we're going to change this from user struct to auth struct. And this is going to be A, then auth, then this becomes A. So we're going to create the method for this later on, but for now, we can remove this. And we're going to have this as auth. Then we're going to have this as login. Then this is going to be a.login. So here we can create the function for login. So func, then associate with the auth struct. Then here we can have login like this. So this is going to be gene contests. Okay, so this is going to be a pointer to gene contests, and we are good to go. Okay, so let's register this auth route. So we come back to the server, we come back to this point, and here we can have auth, then initialize it, then router. We send in the server, and we are good to go. So now just to confirm that we have access to the login route, I want to return something, and I can just copy it from the user route. So I'll just copy this, come back to the auth, then return it here. So yeah, I want to change this to C instead of CTS, and I want to import HTTP. So this is going to be OK status, and this is going to be message. Then this is going to be login route. Okay, so let's see that our server is running. It is. And now we can pull up our postman and change this to auth/login. So it's going to be a post method, and we can send, and we get this login route. All right, so what do we want to do to be able to log in a user? So we are going to specify the params needed to be able to log in a user, and it's going to be similar to what we have for the user. So we have the user params. Let's take a look at it again. Okay, so we have the user's params, and we can use it for our login params as well. And once we get the user data, we can then confirm if the user exists within our database using the user's email. Okay, so once we get the user, we can now compare the password, and that's going to be straightforward. So with all that said, let's actually go through the process. So again, I'm going to have the user, which is going to be new into user params. So we have access to that because we are within the same API package. Then next, I can say if c.should bind JSON into and user. So we're going to extract error from here. So if error is not new, then we can return an error. So this is going to be a bad request error. So we can copy all this and paste. All right, so now it means we have the user information. So the next thing is to get the user based on the email. So db user like this, then our error, then it's going to be a.server.queries.getUser by email. So we have access to that. Then here we can specify the context, which will be context.background. Then we can specify user.email like that. So when we make this type of query, there's a possibility of having two types of error, one being an internal server error, and the other being that the user does not exist. And to check for the user does not exist, we can have if error is equivalent to SQL dot error no rows. Yeah, so that's a possibility. It means that we are unable to get a user that fits into this email. And the response I want to give here, so as not to give the user an idea and start trying different parameters, I'll just tell the user that they have provided an invalid parameter. So something like invalid email or password. So here we are going to add a bad request. So bad request, error, incorrect email or password. Like this. Then also there is a possibility that the error is an internal server error. And here we're going to have the else if. Make sure it's at the back of the closing brace for the if error is not new. So here we're going to return an internal server error. Just copy this. And here this is going to be internal. And here we can have error.error. So the next thing we want to do is to confirm if the password we've hashed matches with the one the user provided. So if we come back to our password.grow here, we can see that this returns only error. And based on that, we can come back to the auth. We can have if error, then into utils dot verify password. So this takes in password, and that will be user dot password. Then the hash password, which will be dbuser.hashed password. Then we can say if error is not new, then that means the password is incorrect. So again, we can return this like that. Then finally, it means the user is authenticated. So at this point, we've confirmed that the user is who they really say they are. And the next thing we want to do now is to return a token that they can use to authorize themselves whenever they want to make a request to our resources. So the next target now is to generate our token, okay? And we can easily do that by going here and creating a token. So here we're going to have package utils. So the next thing is to actually create functions to encrypt and to decrypt our token. And for this, we are going to need a package called JWT. So GoLang has the package to allow us generate a JWT token and to decrypt it. And if we come back to our terminal, we can close this. And we can go get this package, GitHub GoLang JWT. All right, so now we have the package and we can import it. So the next thing we want to do is to create a function to create token. So here we can have create token. So to create a token, we are going to require the user ID because we want to be able to get the user ID later on to associate it with something. So here we are going to pass in user ID of type int64. And I'm getting this int64 from the models here. So the user ID is of type 64, int64. And I'm expecting either a string or an error. So the way the JWT creation works is that you need to provide a payload that is going to encrypt. But this payload is not just an integer 64 or a random type. It's a JWT claims type. And based on that, we are going to create a claims type for ourselves. So here we are going to have type JWT claim, which is going to be a struct. And here we can extend an existing struct or an existing type. So this is going to be a claim, not a claim. So here we can have JWT dot standard claims like that. So this is us extending the functionality of the standard claim type. Then we can now include our own type. So here we're going to have user ID of int64. Then we're going to export it, and we can have JSON into user ID. Then we'll close it up. Then also we're going to need an expiry information. So here we can have this as ESP. Then this is going to be int64 as well. Then we can export it. So now that we've defined the JWT type, we can create one here. So we can have our claims to be JWT claim. Then we specify the value. So the user ID in this case is going to be the user ID we've sent in. And the expiry is going to be based on when we want the token to expire. So by my definition, it's going to be time.now. Then we want to add an extra 30 minutes to it. Add time.minutes multiplied by 30. And we are going to convert all this to units variation. So it's going to be in integer in seconds, okay? So that's what we have there. So this is our claim, also known as the JWT payload. So now to generate a token, we can have token. And this is not expecting an error, it's expected to be successful. So we're going to have JWT.new with claims. So it means we want to create a new token with claims. So we're going to specify a sign-in method. And the method everybody has agreed on. I don't know when they did the agreement, but yeah, they've kind of agreed to it. Is the HS256, this one here. Then we specify the claims. Then finally, we can get the token string itself. So token string. And when generating token string, there is a possibility to get an error. So here I'm going to have token string or error, then token dot signed string, like this. And for this, we are going to need a sign-in key. Okay, so this sign-in key is going to be unique to your application. And to get the sign-in key, I'm going to define it within my AM file. So here I can come here and create a sign-in key. And the sign-in key is meant to be 32 characters. So I'm going to have 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. That's 20. 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. Then 1, 2. So these 32 characters. Now we can come back to our config. Include this. So this is going to be the sign-in key. Let's just copy it from the EM to ensure that it's accurate. And here we can have the sign-in key, like that. All right, so now if we come back to our token, we don't have a way to get it. So it means we are going to provide it here as well. So here we're going to have sign-in key of type string. And we are going to convert that sign-in key to a byte. So here we're going to have array of bytes. Then we are going to include the sign-in key, like that. So now there's a possibility of having an error here, or we get a token string. So if error is not null, or nil in case of Go, then we can return an empty string or an error. However, if everything was successful, we can return the token string, which we need to convert to a string, then nil. All right, so this is the whole operation to create a token. Then we can also create a function to verify our token. So let's do that. So we have function verify token. So again, this is going to take in the token string. Then it's going to take in the sign-in key as well. And since both of them is going to be string, we can just merge them together. So we can have both sign-in and token string here. So we are expecting an ID of int64. So we can have int64 because we are expecting to return the user ID back or an error, like that. So what we want to do here is use jwt.parse with claims, like this. And here we're going to specify the token string alongside the claim struct. So remember, we defined this claim struct, so we're going to specify it as well as a pointer. JWT claim. Then we're going to have a callback function like that. So it already showed the structure for me. So it's going to be a function that gets access to JWT token, an interface, a pointer to it. Then it returns an interface. And an interface in Go is just anything, okay? So just like you have any with TypeScript, you have interface with Go. So you can return anything with interface. So here we can check if the method on the token we have access to here has the same sign-in method we specified. Because that's the whole thing about JWT. It's possible to kind of truncate it, adjust it, and kind of change the way it's signed. So before you can just accept the token, you want to confirm that it's still using the same sign-in method. So here we can have t.method. Then we can bind it to a type. So if the type is of JWT.signin method hmark, so hmark is used when we use HS256 or H-related sign-in methods. So yeah, we need hmark here. And we are trying to check. So it's going to return a result and a condition. So we don't need the result, we only need the condition. And we want to check if that condition is not okay. So here we can say, if not okay, then there is an error. So return nil for the interface, then return the error as well. But we want the error to be sensible, so we can say fmt.error.f. So fmt.error.f creates an error interface. So that's what it does. So here we can have invalid authorization token. So we won't tell it that it's an invalid signing method so that the user doesn't know we know, but we just say it's invalid authorization token. So now we can return the signing key, and the signing key will be used to pass the token. So we have return. We convert the signing key to a byte. Okay, we have the signing key already, so we just have signing key. Then error is going to be nil. So what this is doing is that it's going to use the results we obtained from this function to do the passing. So the function is first confirming if the method of the token is okay. And if it's okay, then we are going to provide the signing key to verify the token. All right, so we are going to get a result here. So we are going to have token or an error. So again, if the error exists, so if error is not nil, you just want to return the same thing. So we are going to return 0, then this. So we are returning 0 because this is expecting an integer 64. Then next, we can obtain our claims from the token. So here we're going to have claims, comma, okay, from our token.claims. Then we are going to bind it to our struct claim, okay, like that. So again, if it's not okay, it means there's an issue with the token again, then we can return this. Then now that we have access to the claims, we can check for the expiry to see if the token has expired. So here we can have if claims.esp is less than time.now, converting it to Unix, then we can return that the token has expired, okay? So return 0, then fmt error f, there we have token has expired. So that's still much more okay because at this point, you know that the token is actually valid. You know that the person is not trying to be smart, but the problem is that the token has expired. Then finally, we can return claims.userid or nil. All right, so we are done with both creating a token and verifying our token. So now we can come back to the user side, or rather the auth side, and we need to create a token. So the token is going to be token or error, going to be utils.create token. So here we want to specify the user ID, which is going to be dbuser.id, then the sign-in key. So currently, there is no way to get access to that config. If we come back to the server, there is no way. But one thing we can do is to add the config as part of our struct. So here we can have config and point it to the utils.config. So now when creating our server structs, we can also specify the config. And that's going to be the config. Like that. Okay? So now if we come back to Auth, that means we have access to config within our Auth, which has access to the server. So here we can have a.server.config.signin key. Like that. So here we can check if we are unable to generate the token, which is going to be an internal server error. So if error is not new, then we have an internal server error. So we can copy this and paste. Else we want to return our token. And we've been forgetting our return statement since. So we have to provide the return statement here, here, and here. So now we have the token, we can return the token. So we have c.json into http.okstatus. Then we have gin.h into token, then equals to token. Like that. And this is what we have for our Auth implementation. So let's see if this actually works. So let's start our server. Here we are going to have make start. All right, so our server is up and running. We can come back here and try to execute this without providing any of this. So just like we have when trying to create a user, we have the same thing. So yeah, that's working. So let's provide the data. Let's provide a run data. So I believe this user exists. So let's say .com1. So let's run this. All right, so it doesn't see this as a valid email. So yeah, that's something. So let's ignore that. Let's make this theory. So incorrect email or password because that user does not exist. Okay, so let's use true instead. I believe this user exists. And now we get our token, which makes sense. And this is the token we'll be used to authorize ourselves whenever we want to make a request and get access to our resources. Okay. So again, we are going to kind of take a break here and go and refresh, meditate on this first. And we'll come back and implement our authorization. And with that, we are going to introduce ourselves to how to create a middleware because we will need a middleware to confirm the authorization. So yeah, that's what we should expect. So see you after the break. All right, guys, welcome back. So currently we have authentication. What we want to work on now is authorization. So now we can authenticate user and confirm the users are who they say they are. But now we need to authorize them to be able to give them the resources they need. And before we delve into that, I want to create an extra endpoint within our user API. So currently we have the users list, which would not be used unless within an admin interface. Then we have the create user, which users can use. So the next endpoint we want to create is to get information about a logged in user. So most times the endpoint is called me. And we can easily do that by having server group.get. Then here we're going to specify me. And here we can have u.get logged in user, like that. So let's create this function. And we're going to associate it with our user struct, like that. So When we authorize a user, we are going to set the user ID within the gin context. So to get this value, we are going to confirm if it actually exists. So here we can have the user ID, then exists. So here we're just going to have c.get, the key we want to get. And when I'm going to save this within our authorization, I'm going to name it user_ID like that. This should be capital letter. Okay. So now we can confirm if it exists. And if you're accessing this endpoint without this being in existence, that means you're not authorized to access that endpoint. So if not exists, then we can have c.json. So here we're going to have HTTP unauthorized. So you're not authorized to view this. Yeah, that's 401. So here we can have gin message not authorized to access resources. All right, so that's what we have there. However, we are not done with our check. When we set something using c.sets, at that point, it's converted to an interface. So we need to convert this back to the type we want. So here we can have converted, OK, into user ID dot int64. So we are converting the interface user ID to int64. However, if it's not OK in this case, then that's an internal server error. It's expected to be OK, because we set the information. So I'll just return an internal server error. Encountered an issue. So yeah, this is going to be an internal server error. Okay, so this should be our converted user ID, which should be of type int64. So next we can get that user. So we can have user, error. Then we have u.server.queries.get user by ID. Then here we pass the context.background. There we pass the converted information. So if this name conversion seems like an issue, then we can change this to something like value. Yeah, that seems it. Then we can change this to user ID. Then this becomes value. So now this becomes the user ID, which makes more sense. Okay. So now if there's an issue when trying to get the user, it means maybe the user no longer exists. So that would be an error of no query. And we've done that before. Let's go back to our auth and just copy that. Yeah, this particular error. So we can copy this, come here and paste it. So remember to always return here. Then return so that we don't proceed to any other part of the code. So let's import this. Like that. So we can have this as at this point, if the user no longer exists, then you are no longer authorized to access resources. So it's going to be an authorization issue. So this is going to be unauthorized. Yeah. Then the other issue would be an internal server issue. So now that we have a user, we can now have c.json, and this will be status, http status.ok. Then this is going to be gin, or rather not gin, but user response. Initialize it to user response. Then we pass the user into it. So we pass it as a pointer. So yeah, we have this endpoint. We implemented this mainly to be able to test our authorization. So I want to remove this user creation from here. I would place it within the auth. So it's going to be register. So here I'm going to have register. and this will be a.register. So I can come here and copy the old create user thing, cut it off. I don't think we need it. Yeah, we can just remove this. Okay, so everything is clean up. Now we can come here and paste it here. So I'm going to change this to register, and we are good to go. So also this has to match with Auth, A, like that. So wherever we have view, we are going to change it to A. And I think that settled everything. Okay, looks like we are good to go. So we have the changes made. And the reason why I made that change is that I want this user endpoint to require authorization. So before you can access any of the route within the user, you must be authorized. Okay? So we are going to create a middleware that we are going to assign here. So based on that, I'm going to come within the API folder and create a new file called middleware. So again, I'm going to target API package. And a middleware is just a function that returns a gene handler function. So it's going to be like this: authenticated middleware, like that. So it doesn't take anything, but it returns a gene.handler function, like that. So that means we're expected to return a function that takes in the gene context. Okay, so that's all we need to do. So we're going to assign this middleware wherever we want to require the authorization middleware. Okay, so the first thing we want to do is to get access to the authorization token. So here we have token into this. That will be CTS, but I'll change this to C. That will be C.getHeader. And the header we need here is authorization. So if token is empty, then we can say c.json http.status unauthorized, and we can have gene.h message unauthorized request, like that. Then also, we don't want to continue to anything. We just want to stop everything at this point. It means you can no longer go further. And we can use c.abort operation to do that. So we have c.abort. Then finally, we have to return. So the first thing is to check if the token exists. However, even though we have a token, the format still matters because we can have different format for our token. So if we come back to here, if we click on authorization, you can specify different types of authorization. But the one we want to work with is the JWT bearer. Once you include this, okay, not JWT bearer, I believe. Yeah, the one we want to work with is the bearer token. And once you include this, your header is going to look like this: bearer, then the token you want to have. Okay? So yeah, that's something to note. And with that at the back of our mind, that means we have to split our token to confirm if it fits into this format. So here we can have token split. And here we want to use the strings operation dot split. And we want to split it at the space center. So here we're going to have token, then split it with space. So bearer and the token is separated by a space, and that's what we want to use to split it. So now we can make our check to confirm if the first part of our token is bearer and if our split is actually into length of 2. So here we can have if length of token split is not equivalent to 2 because it has to be 2, or strings dot to lower. So it means your bearer can be in capital letter or small letter, whichever way you want. Is token splits into array0 if it's not equals to bearer, then you are not using the right token. So we can just copy everything here and say invalid token expect bearer, like that. All right, so now we know that the token is correct. The format is okay. We have obtained token. Now is to confirm if the token is actually correct. So here we can have results or user ID. Let's make it user underscore ID. Or rather, let's use user ID, then error. So here we're going to have utils.verify token, like this. So it's going to take in the token string, which is going to be token splits into the second value. Then we need a sign-in key, which we don't have access to here. And here it says a lot about how we've created our token handler. So let's adjust it a little bit. So for this, I'm going to create a JWT struct. So here I'm going to have type JWT token, like that, of type struct. And here I'm going to have access to config. So now we can have a separate function, func new JWT token. And now this is going to take in the config. So config of type config. And the result we are expecting from here is the JWT token type, like that. So all we need to do here is just return a pointer to this with the config information. Okay, that's all we need to do here. So how does this translate to what we have so far? And it's quite easy. So now we have to associate this function with this JWT token. So we can have J star JWT token, and this becomes small letter, like that. The same thing for this. We can associate it, JWT, then star JWT token, then this becomes a small letter. So now for our sign-in key, we don't need to pass it again. We can remove it. And our sign-in key is going to be j.config.sign-in key. We have access to that now. The same thing for this. So this becomes j.config.sign-in key. So what next now is to adjust where we've used it and actually implement it. So if we come down to auth.go, we used it here. So utils.this and that. So I want to associate the JWT token to my server. So now if I come back to my server, I can say token maker, and this is going to be JWT token, like this. So when I create config, create connection here, I can have JWT token into utils.new JWT token. Then I can specify my config here. So now here I can say JWT token is equals to JWT token. Or rather, token maker is this. So we agreed on that part. So if we come back to the auth, we can change this to a.server.jwt token, or rather token maker dot create token. Okay, it looks like I see the error here. Again, we are trying to work in a different file. So yeah, this should be capital letter, and this should be small letter. So I tend to fall into this pit myself. So here, this should be capital letter, and now we fixed our issue. Okay, so we fix this, and now when we come back here, we don't have access to the server at this point. So it still bears the same question. We are kind of falling into the same pit. And a final way to actually resolve this is to probably come here, have something like var token controller, like that. And it's going to be of type utils JWT token. So instead of assigning it to this, we can remove this. And we can remove this here. So this is now going to be equals to this. So now this particular variable is going to be available throughout the API package. So I can come back to my Auth again, and instead of having it through a.server and scroll, I can just have it as token controller, create token. So yeah, we're actually going to get the same results. Okay, we have to save this. Okay, so now this is resolved. So for the middleware now, we now have this as token maker or token controller, then verify token. So we are going to provide the token splits, and here we are expecting either an error or the user ID. So if an error exists, so if error is not nil, I'm just going to return that error. So here we're going to copy this and paste here. And here we're just going to return that error. Error.error. So finally, we have access to the user ID now. And we can do c.set into user ID. It has to match with what we are trying to get when we created the user me endpoint. So this particular one. So it has to match with this. Okay. Then we specify the value, user ID. All right. So now we've defined the authenticated middleware. And the next thing is to use it. So if we come back to the user.go file, when we are setting up the endpoint, when we set up the group, we can add one more information, and that information is the middleware. So here we want to add authenticated middleware, and that's all we need to do. So let's run our server if it's still running. Yeah, it's still running, so we're good on that note. And let's confirm if this is actually working. So if we come back here, if we go back to users, if we try to get user, we shouldn't be able to if we did not specify this. So the token we have here has expired. Okay. So let's not specify a token at all. So no auth. So unauthorized requests. That's what we get. So it means before we can list out the users, we need to be authorized. So let's put in a random bearer token. So let's just have OA and let's send. So invalid authorization token. So we get all the information we need. So let's log in and try this again. So we have auth, then login is going to be a post request. And we can copy our body from here. Let's log in. So now we can log in and we can copy this token. So let's come back here. Let's specify our token. And let's send. And now we can list out the users. So let's try our me endpoint. And as you can see, it got us the logged in user. So yeah, that's actually what the aim for this episode is, and we've been able to cover it up. So now we have the CRUD operation for users. We can create user, update user, delete user, and so on. And also we can authenticate user and authorize user. So we are meant to have a UI at this point, but I can assure you we've spent a lot of time doing this already. So I want us to have a very long break while pondering on what we have so far. Let's rehearse on it so well. Then in the next episode, we are going to implement it on our front end, which I believe should be rather easier than what we have on the back end. So until then, keep coding and don't relent. Bye for now.